Hey, welcome back. So in this video, I thought we'd spend a little bit of time with structured outputs because it's now available in Ollama, and the new Microsoft Phi4 model, which has just been released, is actually really good at handling structured outputs. It's not quite as good as OpenAI, which I'll show you in a second, but structured outputs, I believe, is the key to unlocking inference time compute. And I'm going to show you later on how that can be used for multipath solutions and reflections when we go to solve Sudoku problems. And if you haven't heard of structured outputs before, it's quite simply the ability to specify a schema that you want the large language model to return its response in. So it's this ability to specify a response format. Now, if you think about that for a second, large language models have got the ability to hallucinate, they go off in different directions. And when you're dealing with things like APIs, or if you're trying to do something with a little bit of reasoning, for example, and you need it in an exact format, if the LLM produces it in a slightly different format from what you're expecting, then it's not going to parse and you're not going to be able to do the thing that you need to do. So it's absolutely critical for things like function calling, and that's why structured outputs is now the way of powering function calling for OpenAI, and I assume in the future with Ollama. However, it has got much wider implications. So I'm going to give you a very simple example, and I'm going to do a verifier example. And what the verifier is going to do is I'm going to provide a question such as, is the sky green? I'm going to provide a user's answer, and then I want the model to come back in the exact format that I specify, whether the user was correct, and the explanation behind that. So to bring that to life, I'm just going to run this simple script here. We are going to create this manually for ourselves, but I really just want to see the output. So you can see in this case, the question is the sky green? The user answer that we provided was yes, and then the model has then reflected upon this, and then it's come back with correct answer. Now here's a key thing here. You see false? So this is a Boolean. So I'm wanting it to come back as a Boolean answer. And you can see this up in the schema as well. Question, title, type is string, answer is going to be in string. Correct answer type is a Boolean. And again, that's critical to this parsing side of things. So this schema here, which is a JSON schema, is what I'm going to provide to the model. And then the model, when it gives its answer back, is going to provide me a piece of JSON that validates to that particular schema. And again, if we go through that a little bit more, I have an explanation. The sky is typically perceived as blue during the daylight, blah, 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 blah. So to get started, I'm going to create a very, very simple file. We're going to call it supersimple.py, and then we're just going to open this up in VS Code. Now, as I said before, we're going to use Pydantic models because, to be honest, specifying JSON schemas are a complete pain, and we could actually just do this by creating a Pydantic model and then have that generate the schema for us. So we are going to do the verifier question that we did earlier. So we're going to ask it, is the sky green? And then in order to do that, we need some sort of model there. So in this case, we're going to use Pydantic. So I'm just going to say from Pydantic import base model. And then I'm going to create a new class. And in this case, it's going to be called a yes/no verification plan. And then, of course, it's going to inherit from base model so that we know it's a Pydantic object. Now, the advantage of having a Pydantic object is obviously it can serialize JSON, which is going to be the format that comes back from our model. And therefore, I don't really need to worry about the innards of JSON schemas or producing the JSON. I can just work with Pydantic objects as I would normally do in Python. So I need a couple of things. I need a question, and that's going to be of type string. I'm going to need the answer that the user is providing, and that's going to be called user answer. And again, that's going to be of type string. And then, of course, I want the model to come back and say whether it was a correct answer, and that is going to be of Boolean. So we know what the user provided as an answer, and we know what the correct answer is, and we now need something that tells us whether the user was correct. So we'll create a property called isCorrect, and that is going to be of type bool as well. And then finally, if there's an explanation from the model, then we want it to be able to put this within a string field, which is going to be called explanation. That is our Pydantic model. It's really as simple as that. So all I'm going to do now is I'm just going to very quickly hard code in a plan before we call the model, and that's just to test that everything is created in the way that we want. So in this case, I'm going to set the question equal to is the sky green? The user answer in this case is going to be yes. We're going to say the correct answer is false, and then we're going to say is correct is also going to be false. And we're going to say is correct is false in this case because, of course, the sky isn't green. The user said it was. The correct answer was false, and therefore the user is not correct. So it is correct. It's going to be false. And then we'll just put an explanation in here. And we'll just write the sky is blue. Okay, so we've got our yes no verification plan. And then what I really want to be able to do now is just print out the schema. One of the nice things about Pydantic is I can just print out that schema directly. So to do that, I am just going to say print plan. And because it's a Pydantic object, I can just call model adjacent schema. And then that is now going to print that out. And what we'll also do is we'll print out the JSON. So in that case, to do that, all I need to do is do a print. And rather than calling model JSON schema, I just need to call model dump. Now, finally, all I need to do is call my main function. So if we come back to my terminal for a second, and we rerun Python super simple, you can see here, I'm going to have my schema. And then I'm going to have my JSON coming back there. And it's exactly what we had before. So the question is the sky green, user answer, blah, blah, blah. I have not called the model at all just now. This is just us proving here. So I've easily got access to the schema by calling model JSON schema, and that's what we're going to use to pass to Ollama. And then the JSON here is very, very simple. I am literally just outputting the JSON using kind of model dump. So Pydantic objects make it really easy to work with. Okay, so we're now going to enhance this a little bit, and we're going to go and talk to, we'll actually talk to OpenAI and Ollama, because I think that will be important because it'll allow us to kind of see the differences between the two. So to be able to do that, I need to set a system message. So the system message in this case, I'm going to have a role, which is system. And then my simple system message is going to be pretty simple for this. It's just going to be, you are an expert at verifying yes, no questions. And then I'm going to say output valid JSON only. So I need to direct the model to push JSON there. Sometimes the model can go off a little bit. So actually one of the things you want to say in your system message when you're working with structured outputs is just output valid JSON only. The next thing that I want to be able to do is have a user message of some sort. So I'm just going to come back into my main, and then I'm going to call this user message. And I'm just going to set the role to being user. And then the content in this case, I am just going to say something like, is the sky green? And this is what's going to be passed to the model. So I'm saying what the question is. And then I'm going to say the user answered yes. Now again, this is very, very unstructured, but this is what we're going to pass to the model. Now, if I pass that to the model directly, then I could get that in any kind of format that you could imagine. In fact, if I wanted to, one of the things that we could do is I could just issue a curl command to Ollama. I'm going to talk about Ollama in a second. So I'll just call 11434, which is where Ollama is hosted. So Ollama has a fast API server. I'm going to use the model Phi4 as we said before. I'll show you how you can get that in a second. And then prompt question, is the sky green? The user answered yes. And then I'm saying system, you're an expert at verifying yes, no questions, output valid JSON only. The key thing in this is I haven't provided a format, so we can see what's going to come back. And you get the idea there. It sort of came back here with an answer, but it's not really an answer that I want. It's not in the JSON format that I want there. You can see response JSON, is the sky green, blah, 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 blah. It's streaming that out at the moment, but it's not the format that I would want to specify. So if you want to be able to install Ollama, just go to ollama.com and then you can click on download and install that. I do have a video which deep dives Ollama, so feel free to check that out. If you want to know more about the Phi4 model, I did a video on that recently as well, and that goes into all the details and what it's good at, what it's not. I'm not going to do that today. But if you want to get the Phi4 model, all you need to do is Ollama pull Phi4, and then it will go and download that. And then if you want to see that in Ollama, you can type Ollama list, and then you can kind of see at the top there is Phi4. So this is pretty much as simple as that. If you want to talk with the Phi4 model directly, you can just do Ollama run Phi4. That's going to open up an interactive chat line. I could just enter in something like, question, is the sky green? The user answered yes. And you can see that's the same sort of answer as I had before, but of course it's not in the format that I want. Also, if I wanted to, Ollama does have the ability to run a JSON mode itself, so I could just do minus format JSON there for a second, and then I can put in the same question. And you see it's going to come back with JSON there, and that's pretty good. It's a JSON format, but it's not in the schema that I want. So this is kind of the major reason that we are using the structured outputs, is that it allows me to specify the exact format that I want, and therefore I can parse that. Okay, so now that we've done that, we actually need to interact with the models. So I'm going to get rid of this yes/no verification plan that I hard-coded, and then we're going to create a new function called verify, and then I'm going to set system message is going to be equal to system message that we specified earlier. User message is going to be equal to user message that I just put here. Response format is going to be equal to the yes/no verification plan that we specified. So the big thing that I want to be able to do here is when I go and do this verification and call Ollama, what I really want to happen is I want to pass in the exact Pydantic class that I want it to use. And then underneath the hood, it's going to use the model schema JSON to then be able to feed that into Ollama. And then finally, the model name, I'm going to pass in Phi4 as the model name. So we'll just put in Phi4 here. Now, obviously, I haven't defined my verify function, so we need to do that to talk to Ollama. So to do that quickly, we'll just create a new function. We're going to call it verify. And in that, I'm going to accept in a system message. As you can imagine, I'm going to accept in a user message. I'm going to accept in a response format, and I'm going to accept in a model name as we did before. Now, what I'm quickly going to do is just create a nice list of messages. So in this case, the list of messages is going to consist of the system message, and it's going to consist of the user message, and we are going to pass that into Ollama's kind of chat history. So next thing that I need to do is I want to be able to chat with Ollama. To be able to do that, you are going to need to import Ollama. So I'm just going to put that in here. So we need a from Ollama import chat. In this case, I'm using UV. You can do a pip install Ollama, or if you've got a UV project, you can just do UV add Ollama and add it into your project in this case. So you will need the Ollama dependency maintained. Similarly, earlier on, if you're probably complaining, you need Pydantic as well. So pip install Pydantic UV add Pydantic. Now that I've done that, I can just do response equals chat. And I'm just going to set the model equal to model name. So I'm going to set messages equal to messages, which is that list here, which consists of our system message and our user message. And then this is the key thing for making this work with Ollama. I have this thing called format. And then what I want to be able to do here is I'm going to set that equal to response format. And then the key thing that I need to do here is do a model JSON schema. And then effectively what that's going to tell Ollama is here is the JSON schema that I want you to be able to run to. So now all I need to do is return the parse object. So to do that, I am just going to return response underscore format, which is our response format that we passed in. And then I'm going to call model underscore validate JSON. And then I'm going to pass in our response dot message dot content. And then that will return the parsed Pydantic object. So now if I come into my terminal, remember I am running UV here, so because I'm running a virtual environment, etc. So I'm going to type in UV run simple.py, and now it's going to call Ollama. It's going to call the Phi4 object, and then you can kind of see here, is the sky green was the question. I said yes. The correct answer is false. So this is coming back with the model. The model has filled this in the exact format that I want. Is it correct? The models came back and went, no, it's not correct. It's false. And it's given an explanation. The sky is not typically green. It appears blue during most of the day, blah, 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 blah. So that is the big thing that it's doing, right? It is taking this and putting it into a format that I need. Now, that's pretty cool. So that is verifiers, and actually verifiers are super, super useful, right? So if you think about how inference time compute works, I think they actually OpenAI talked about this during the kind of 12 days of Christmas, this idea of verifiers. But if you want to do a kind of model teacher and then have the model learn from itself, Then you can ask the model a question, get a list of the answers back, run a verifier, give an answer, and then it can come back with the answer. Now that I'm parsing that object, I can do that within loops, and then I can build up a better training data set. And again, I have a whole video on the star paper, and again how verifiers are used as part of that, so feel free to check that out. But you can kind of see here that you can implement verifiers with Phi4. It does work with other models as well. It doesn't need to be Phi4. I could do change the model name to Ollama 3.1, for example. Come back in here, let's just clear this and run this one more time, and you're going to see that we're going to get a completely different response. Comes back a bit quicker. It's a smaller model. Sky is green, user answer yes, correct answer false, is correct false, explanation of sky is not actually green, so the user's answer was incorrect. It's not a great explanation, but it's an explanation, right? Again, I'll switch model again. I'll use the IBM Granite model in this case, the Granite 3.1 dense. Now, where we want to get a little bit more complicated, as I said, I want to get into doing some Sudoku stuff there for a second. Rather than you watching me type that out for a second, I'm just going to use a script that I've created before. It's exactly what we had here. So in this case, the user message is going to be, please verify this completed Sudoku puzzle. So you see I'm providing this Sudoku puzzle as a grid. And by the way, it's an invalid Sudoku puzzle there. And then I'm going to ask the models to kind of verify this. In this case, I have a Sudoku verification plan. So you see it's a different type of plan there. So in this case, it's a Sudoku grid. And then you can see what I wanted to do is verify each line, each column, and each grid, and then come back with the answer. And I want it to return the Sudoku grid, the verification details, the overall result, and any kind of final notes there. Now, I want you to show you, I'm going to show you a difference of a couple of the models there for a second. So we're going to start with Phi4. The big thing that I want you to see here is the system message. So if we go to the system message, I'm going to start with a really simple system message here, which is you're an expert at verifying Sudoku solutions, return as JSON. Again, I'm convincing the model to do this. I want you to see that it's actually done a pretty good job there. It said this is Sudoku selection is correct, and you see line 5 has a duplicate 1, column 9, and it's came back with invalid. So again, it's done a good job there. It's given me an overall result. It said the final note, and then it's done the line by line verification. Now, I'm not a big fan of that chain of thought, and the reason I'm not a big fan of that chain of thought is that it's not listing out each number individually, and I think it can kind of miss things if we did this. So what I've done in this particular case is I've given this a better system message. So we'll toggle that off here, and we'll just toggle this in here. And I'm a lot more specific in this sense. So you're an expert, return a JSON, and then I've given it how I want it to do it. I want row 1, row 2, etc. to come back to here. So I'm really sort of guiding the model into the production. So if we run Phi4 one more time, and now you can see it's done a much better job there. So it's given this overall result, invalid, Sudoku puzzle was found due to duplicate row 5, subgrid 5. And you can kind of see it's done a fairly good job here. Line 5, and you see digit 1 appears twice. There's digit 1, here's digit 1. So it's followed the instructions and then brought that back. Now watch when I do the exact same prompt, but this time I'm going to do it with OpenAI. So to do it with OpenAI, I'm just going to change from Ollama here. You see I'm using LM client's Ollama client, and I'm actually just going to use OpenAI client. I'm going to show you what that looks like in a second, and I'm going to have a verify function. And again, it's the exact same signature as you had before. I'm going to pass through the Sudoku verification plan. And then rather than talking to Phi4, I'm going to talk to GPT. I'm going to talk to GPT 4.0 rather than anything else. Now, if we just run the same command again, obviously this is not going to run locally. It's going to go and talk to my OpenAI API. Now look at this. And again, it came back with the exact same numbers. Again, one more time, if I switch the system message rather than using this version, and then we'll come back to my more detailed version, for example, and we'll just toggle the line comments. And then we will just run this one more time. You're going to see that it's going to come back with a pretty good answer. And there we go. If we look at it again there, it's picked up the error. Digit 1 appears twice. It's listed that out, and it's gave it the same answer as Phi4. So GPT 4.0 and Phi4, from a kind of reasoning perspective, it's actually coming up with pretty much the same answers with the same system prompt. And it's done a really good job in this case. Now, to bring this home one more time, just before we get into this, if we actually have a look at the OpenAI client for a second there, there's a couple of things I want to kind of point out, which I think is probably a little bit important here. There's a couple of changes in the way that you interact with this. With OpenAI, you don't need to do the model schema. piece, the OpenAI client deals with that automatically for you. So you just need to pass through response format. You don't need to pass the model schema. And then the other change here is you notice it's using client.beta.chat.completions.parse. So it's a slight difference on what you're calling there. And then returning the parse message, you're doing response choices message.parse. But apart from that, is pretty much identical. But it's given a kind of similar response. Now, the last thing I want to show here is, so I promised we were going to be a little bit agentic and we're going to do a little bit of reflection. So we're going to do one more example. And I've created this one called Sudoku second pass, which has got the exact same system message as we seen before. We'll maybe start with the OpenAI client for a second, and then we'll do Phi4 there. What we are actually going to do here is I've got a slightly more complicated grid. So what you're going to see is that the rows and the columns are pretty much okay, but the complication is in the center middle grid, 5, 4, 3, 1, 6, 7, 2, 8, 4. Most of the models get this wrong. So when the reasoning models tend to get it right, but when I pass this through to things like Claude, etc., this particular grid, it tends to mess it up. It gets columns and rows pretty good, but it seems to mess up when dealing with the subgrid. So what we will do here is we'll run this with OpenAI, and then we're going to run it with Phi4, and then we'll see the difference. Now, the big thing about this is I'm going to do two passes. I'm going to do a pass of the grid and get its first answer, and then I'm going to take the answer that it gives, and I'm going to run it through a second pass, and I'm going to ask it to verify again or correct any mistakes. And then it's just going to call the Sudoku verification plan one more time. So now that we've got that, we're going to run a script called Sudoku second pass. So as you can kind of see here, if we look at GPT-4o for a second, the first run that it's run is went through that Sudoku grid and it's came back with success, success, success. Now we know it's not a success because if we look at a couple of the columns there in the subgrids, as we proved before, there is duplicate value. So see here, subgrid 6 has picked up 9 and it's picked up 9 there, although it's marked as success. Now it's done a second run of the plan. Here's the second pass, and it's went through and it started to pick up stuff. Now it's hallucinated a little bit here. It thinks the error digit 9 appears twice in row 9, but I suspect it's that row 9 that it's in the row here that it's kind of just confusing it a little bit. But down here, look, those subgrids, those problematic subgrids, it started to pick this up. So you see digit 9 appears there twice, digit 9, so it's picked that up on the reflection, digit 9. So I don't think it's perfect from a GPT-4o, and I've only done a second pass there, but you can get the idea that with inference compute, that it is actually going to make a pretty good job, and therefore the more times you can iterate over that, and using structure like structured outputs to say this is the exact format that I want is going to make a big difference. Okay, so I switched it back to Ollama there for a second, and then I put the model set to 5.4, and then we're just going to run this and then see what happens. So exactly like we did with the OpenAI version, we're going to do a first pass of the model. So it's just going to try and validate that grid. And then once it's got that, it's going to run a second pass and try and validate it again. And you're going to see the difference. And this, I think, is really the key thing in test time compute or inference time compute, which is this ability at runtime to be able to follow a plan. And I think the ability to follow a plan is because if you are able to use structured outputs and be able to put that into an object, then you can for loop over that at inference time. It's in the exact format that you need, and then you can go and specify a few things from that. So the first thing to notice here is 5.4 has got it wrong on the first pass here. So you can see Sudoku verification plan, overall result valid, and then it's saying it's valid, all rows satisfy the rules, success, success, success. So if we look at what 5.4 has produced for a second, although it's done a fairly decent job there, it is able to kind of do the reflection and pick up stuff. Unfortunately, it's not been able to track the grids properly in the same way as GPT-4o was, and you see it hallucinating 217, 956, 438. That's correct as line 9, but it's not been able to pick up the grids, and then it's sort of done a variation of the same down there. So it's not picked up the grids that you would expect. Whereas I think if 5.4 was able to have better chains of thoughts and then be able to track those grids in the same way as GPT-4o was, then it would be able to do a pretty good job. Now, for a little bit of fun, I'm just going to change this from 5.4 to the Qwen 2.5 Coder 32 billion parameter model, and then we'll just see how that does. So as you see, the Qwen model's as good as it is, it's actually not picked that up on the second pass either. And the reason it's not able to pick this up is that it's got itself confused again on the subgrids here. So if we look at that subgrid 5 there, 543167829, it is actually not what our grid was there, and therefore it's went through and then it's kind of verified as success. So I think the only model there that has been able to do that pretty well is GPT-4o. 5.4 got itself a little bit confused. What I would say is 5.4, the Qwen models are all doing a pretty good job, but if you can generate consistently the right chains of thoughts into the right structured outputs there, then we're going to be in a scenario where you can just iterate over. You saw that with the GPT-4o model. It was able to iterate over and then come back with the right answer. So as you can see there, 5.4 and Qwen, they've had a good attempt, but they're not quite there. Structured outputs is super powerful, but the models themselves are not tracking as well as things like GPT-4o is. And I think as that improves and as structured outputs improves as well, then I think we're going to be at a really good point where this is going to drive inference time compute. Anyway, I hope you found this video useful, and I hope that this has given you a better idea of how structured outputs works and why it's so important, in my opinion, to inference time compute. But actually, it's super important for things like function calling, because it's what powers function calls. It is why that when you call an API and get a response back, you're able to parse it in the right way, is because the model is able to output the JSON in the format that you want. And it's super cool that it's now available with Ollama, and it works pretty well with a bunch of the models. Anyway, I hope this video has been useful, and I'll catch you on the next one.